Visible to all?
Yes, sir.
Yeah. So to avoid any possible further delay, that's why I actually suggested Pranati to conduct this lecture online. Not bit sick, I mean not bit comfortable, but sort of to continue this class through the online mode. So before we will proceed, as I discussed that today the purpose of our discussion is to consider some real life scenarios where PLC based programming or PLC based automation can be done to execute the real application scenarios. It can be industrial, it can be commercial, it can be defense purpose, it can be healthcare, in the across the various sectors, right? It can be a power grid, it can be a close periphery industries, maybe it's like aluminum or steel making or any heavy engineering plant. So under this particular scenarios, today we are going to discuss the uh, uh, case where we will supposed to program an elevator. Okay, as it is depicted in this figure number 8.19. I'm referring the book of Curtis Johnson. So as per that, it's the basically example number 8.6 or the chapter number 8. So here you see in this diagram what is trying to dictate. Obviously, it comes under the discrete state process control application. Is it can be continuous mode? Yes, there are like one application we will see. In fact, the nowadays, because mostly the controllers are digital in nature in commercial, for as far as the commercial application is concerned. So either we will supposed to deal with the discrete state process control, or we will supposed to deal with hybrid state. That means analog and as well as discrete state. This is an example of discrete state. It means all the operations are being executed in terms of the digital mode. Okay? So let us take the example of this elevator. So what is supposed to be seen here? Assume that there are only two floors. There is a ground floor and then there is a top floor. Okay. Now, if I will compare this with example of your hostel, maybe your hostel is 4th floor or 8th floor. Then in between the top floor and the ground floor, there will be certain n number of floors will be there, and accordingly these number of steps, you see there is a like nozzle here which is basically used to demarcate 50% of the recovery of the distance done by the elevator. Okay? So now you can relate with the binary state. So if the number of ground floor and the top floor, or I would say first floor, then these number of switches will be kept on increasing, other than the two common switch, that is start the operation and stop the operation. And remember, these are the very specific switches. So for physical and also, as we have been discussed that throughout our lecture series, we will consider ladder logic diagram for the programming purpose. Ladder logic is one of the 5 languages by which you can program a PLC. We are using a ladder logic here, which is a low-level language, right? So when you will develop the ladder logic program, there are 2 stages, physical stage and then the programmable stage. So we will discuss physical stage first, and then I will try to correlate the programmable stage. Once you will be a professional automation engineer, as I said already, you can skip the physical part. You can directly go for the programmable part. But it is always advisable to go for a physical part so that the nomenclature will be clear to the operator and you will be not attempting any mistake. Now, coming back to this topic, here you see there is a 2 motors are fitted here. Why? Because there is only 2 floor. Assume that this slide is a ground floor and this slide is the representing the first floor or the top floor, okay, of your hostel. Now To demarcate it, to start the operation, there is a switch PB. PB means pressure button, push button you can say. So it's a push button 1. Stop switch is indicated by push button 2. Up location, that means whenever you want to move from ground floor to first floor, so it is a up direction is indicated by the, will be executed once you will push the push button 3, PB3. And to reach the ground floor or the safest floor, I would say, okay, that is will be executed by PB4. Why I say safest floor? Because, for example, you are in the elevator, many times you might have experienced, then the grid is unable to supply the power, maintain the constant power. So what happened? Elevator should stop there itself. Should the elevator halted there itself? Answer is no. It should reach to the safer point and then the door should open so that the entrant can come out from here, passengers can come out from here, and then either it can be closed or in the safer side, because it is a power failure, so it should be remain open, right? If it is happening in the top floor, then in that case, the elevator should automatically reach to the ground floor because that is the safest condition and it should be remain there. Now, is it a by default scenario for all the elevators? Answer is no. You have to program that to consider all the fail-safe operations to meet all the safety measures, right? Now here you see in this diagram, two switches are mentioned, LS1 and LS2. Can you correlate it? It is called limit switch. Limit switch 1, limit switch 2. Whenever the limit switch 1, that means, for example, you want to move elevator from this elevator from down floor to top floor. You want to reach to the top floor. So which button I need to press? I need to press the PB3, right? For PB3, the start and stop button should have been by default energized. How it will be done? So whenever I need to reach from ground floor to first floor, this limit switch 1 should be energized. It's like a relay, you can say. Okay, this limit switch 1 should be energized. If limit switch 1 is energized, then it will energize the motor M1, and M1 will pull the this level or station towards the upward direction. Here you mentioned M1 is a motor for up motion, M2 is a motor for down motion. Likewise, whenever I want to reach from top floor to ground floor, okay, what you will press? You will press down button PB3. Down button PB3 will ask LS2 to energize. Limit switch 2. It is a down loop. Once LS2 will be energized, it will energize, ask motor 2. It will give the direction or energy to motor 2 to rotate. That means drive in a particular direction. Accordingly, this pulley will be rotated in a particular direction. So this elevator will come from top floor to down. I hope that this idea should be clear to you. Now consider that here you see, like before that I am showing you, there are like certain symbolic representations. So purposely I have asked about to like copy it and share with you. So both guys have done this job, okay, on a very promptly. And, so here you see that like how the representations can be done for the normally open switch, normally closed switch. Any timer operation is related like this symbol what you see. That means it is not only a simple switch, it's a timer based relay switch, for normally open or close. Motor, how it can be indicated, solenoid, how it can be indicated, output device, how it can be indicated. Okay? Physical limit switch, pressure limit switch, temperature limit switch, different things are given. Accordingly, you can use it for your programming purpose. Coming back over here. Okay. So now you see the problem. Okay. The elevator is already given. You see that the following hardware specification is defined, the equipment in the elevator. These are already given to you, available. If not, as a programmer, you will be supposed to think it and according to consider and then you program it. Okay. So two motors are given. M1 is responsible to drive the platform in upward direction. M2 is responsible to drive the platform in downward direction. Here you see two limit switches are given. Here see, it is mentioned NC limit switch. That means both the limit switches are already closed. Okay? Can the condition be different if it is NO type? Yes. Can the condition of programming will be different if the stop switch is NC type or means that means normally closed? Yes. Accordingly, your solution will little bit modify or change. You have to change it, right? Here in this scenario, limit switch 1, limit switch 2 energizing relay are already normally closed condition. That means they are by default energized. If there is no power failure, LS1 and LS2 will remain energized. Okay? Start button is a normally open type button. That means I have to push it to close. Stop button is also normally open. I have to push it to close. That means to stop the function. That means wherever the elevator is faulted. Take start button, start the activity. So whenever I will press the stop button, do you think that the elevator should stop there itself? Then it would be a bad idea if somewhere you are in the middle of the path. So stop button pushing means that whatever the nearest floor, it should reach to there and then stop the function. Up button is a dedicated button, normally open type button to address the up command, and down button is for the down command. Okay? Now here you see, these are the narratives given to execute this program. Okay? These are the conditions. What are the conditions given? When start button is pushed, whenever you are going to push the start button PB1, the platform is drive to the down position. Why down position? Because ground floor is the safest condition. Maybe power failure was happened. Maybe after malfunction some maintenance was happening. Okay? So whenever such interruptions will come, once everything is normalized, where you should find your elevator? You should find your elevator at the downmost floor. If it is a ground floor, it's ground floor. If it is designed to operate like from first floor to top floor, like the new arrangements is being done or programming is being done to operate in what you call your pull-up hostel. Okay, so probably what I came to know that now the elevator will move from first floor to 8th floor, top floor after the reprogramming it and reinstalling it. Okay, so accordingly you can plan. Stop button to stop the operation. Here is mentioned the platform is halted at whatever position it occupied at that time. It should halt it. It should stop that. Even better approach is that it should come down to the nearest floor, right? Whenever up button is pressed, if the platform is not moving in downward direction, for example, like one among of you is little motorist in nature, platform is moving in upward direction and you are deliberately pushing the down button, that means PB4. Do you think that your elevator should address your concern? No, it should override it. Let me finish my job first, then I will come down. Right? The same condition is for the down button. Down button will ask the elevator to come down if it is not moving in the upward direction. If it is already moving in upward direction, it will execute that task first and then it will come down to the down position, that is in the ground. Okay? So to do that, you see that the two critical operations, start the operation is very important, stop the operation is very important. So how can we address it? So let us go one by one rather than thinking about all the program one stage. So remember, it is still physical ladder logic diagram. Okay. So now you see over here, as you can see in this arrangement, PB1 is push button 1. Here you can say it's push button 1 to start the operation. Whenever I will start the operation, what should be done? Platform should reach to the downward position, right? Now to reach the downward position, which limit switch should be activated? LS2, correct? So limit switch LS2 should be activated. So here I activated normally LS2. LS2 is already energized, is mentioned. So that means it is in closed condition. Now to execute this task, because it is a push button, you know that if I will remove the pressure, what will happen? It will again open. Disconnect. So to remain in connect, I will consider as a relay. CR1 is a control relay 1. So I'll use the control relay 1 to execute my start operation as and when needed. So I am defined it is rung number 1. And to do that, I'll take one more normal button, and that is input button here, considering the same nomenclature. So whenever now CR1 is energized, accordingly this button will energize. Now even it is remain open, the next time the current will flow in this direction. This we have been already discussed, right? Now, once CR1 is energized, it will ask which one. Control relay 1 is energized. When control relay 1 will be energized, whenever it will be connected to LS2 and the PB1, LS2 and PB1 together, then what will happen? It will ask motor M2 to do your job. What M2 will do? It will try to pull the elevator towards the downward direction. So therefore, motor M2 is indicated here. Okay? Now question comes, can I connect this motor M2 like here? Did you get the point? CR1 is already here. Can I connect this motor M2 here itself? Anybody can answer? Hello? Remember, no. Hello, am I audible?
Yes, sir, you are audible.
Yeah. So remember that doesn't matter. You can connect n number of things at input stage, but output will be remain only one and a unique at all, in irrespective of the circumstances. Any output will be remain only individual. You cannot operate two output through the same line. Okay. PLC is never designed for that purpose, for the safety purpose. That is the reason why we are again writing CR1 here and we are connecting M2. Remember, it is not a very smart way of programming, but we are initially trying to understand as a level. That's why we are using more and more number of components to execute the easy task. Is this line is complete? Is there is no conflict of interest? We will see later on. Probably these two lines we can modify it, especially the second run we can modify even further. Why? Because which motor I am using here to execute the start operation? M2. Which motor I will be using to execute my down operation? Again M2. So you see there are some connectivities established. Now if PB3 is active, do you think that PB4 should active? No. Vice versa. If PB4 is active, PB3 should close. Right? If PB3 is active, PB4 is active, PB3 should be inactive. So we will consider all this scenario later on. Okay, but right now you think that I just have to start the elevator. For that purpose, these two lines are more than sufficient. Likewise, you see, if I want to stop the operation only, then what can I do? So for stop the operation, there is a PB2 button you see over here. So to stop the operation, remember it is the most important button. Stopping any activity safely is the most critical scenario. So CR1 we have been allocated for start the operation. Now what I will do, it is a separate activity. I'll allocate one different control relay. So let me name it CR2. Okay? So whenever push button will be pressed, CR2 will be activated. Okay? CR2 is going to stop the activity. Okay? This one line is more than sufficient. Theoretically, yes. Practically not. Why not? Because now you see there are two relays, CR1, CR2. Will I take more relays? Yes. For example, CR3 I will take. You can do these changes with respect to the current program I have been shared here in this book. Okay, even that will be more easier for you. I'll show you why it will be like relatively easier for you. Okay. So you see over here, that for example, I'll take CR1 for execute start operation, CR2 for stop operation, CR3 for up operation, CR4 for down operation. Now there are more than one control relays. Don't you think that there will be a conflict of interest? Possible, right? So to avoid that, what we will do, we will keep a master relay. CR5. What in this book, in the order, sequential order, it has mentioned CR3. So as per the this author, CR3 is a master control relay, remember? Okay, you can write it is MCR, master control relay also. Or you can write CR3. Okay? I would personally prefer to write it CR5. even for the better understanding. Why? Because I can correlate with these buttons. CR1 is my control relay for start operation, CR2 for stop operation, CR3 for up operation, CR4 for down operation. Get it? Okay. So in this scenario, what will happen? That what will happen? I'll take CR5. So okay, in any way, even you will take CR3 here or CR5. What is happening here? You see, if the stop operation is active, okay, do you think that the start operation should be on? No. So that means CR1 and CR2 are as good as like the adversaries. One is functioning, another should be inoperative. Now, right now, CR2 is energized. That means it is normally closed. So you see here I indicated normally closed. Okay. Now this indication will be go to CR3, or for me it is CR5, for example, personally if I will take. Okay. So this CR3 is a master control relay. You can write here master control relay. Okay. And if CR2 is closed, but CR1 is open, then the line will complete to energize the CR3. Okay. There is no start operation. Stop operation is there. So CR3 is now asking the control relay to do your job. What is the job? Stop the operation. Done. Now, because it is operated through the push button 1, so obviously once CR3 is energized, I will take the CR3 in parallel to this so that CR3 will remain energized all the time. Why all the time? Because CR3 is the master control relay. Okay, doesn't matter, you will execute CR1, CR2, CR3, CR4. Okay, okay, CR3, which is a master control relay as per this author, will be remain energized to handle all other control relay operations from CR1 to CR4. Take 1, 2, 3, 4, and 4, right? So therefore, this is the condition is there. If you will particularly execute rung number 4 properly, then you say that your stop operation is complete and it is not in conflict of interest with any other operation. It is taken care everything. Start operation should not be on, normally open. Stop operation should be active, normally closed. Then only CR2 will do its job. This output device will do its job. This is output device. This is output device. This is output device. This is output device. All these are the input devices. Right? Now, you remember that we have been already taken our assumption that we will take the what you call start stop operations through the just hold on. We'll do later on. Okay, so let us continue this activity. Done. Okay, so the purpose is already explained here. So go through it. It's very, very like vital. Okay, now you see over here. Forget about the rest of the things. I am trying to be here with only these 4 steps. We have discussed the 4 steps. You see over here. Now we are recombining and you see all these 4 steps here. Okay? All these 4 steps here. Till this limit. Push button 1, start the operation. Okay. What push button says? That bring the elevator down. To bring the elevator down, there was a limit switch 2, which is already energized. That means close. This is a limit switch like symbol. So it will operate CR1. Once CR1 is energized, it will energize this input CR1. Okay, both are same, so both will energize at the same time. Because it is remain energized, so now the current will flow uninterruptedly in this direction whenever you are going to execute the start operation. Now you see, in previous diagram here I have been shown you this is the activity of operating motor 2 because this is also output. So I will again take CR1 and I will connect it, right? Now here you see some changes over here. These are some additional guys here. What are these? We will see little later, don't worry. To stop operation, these two will execute start operation, these two will execute stop operation. So here is PB2, it is CR2. CR2 is stop operation, CR2 is remain closed, CR1 should remain open, and CR3 will remain energized. So that means this line will be incomplete. That's the reason that you keep CR3 in parallel to CR1, not CR2. There can be answer question. Even I want to keep it parallel. Can I keep it parallel here? You can, but purpose will not fulfill. Why? Because how the circuit will close? Circuit will close because only CR1 will be normally closed only whenever you have to execute start operation. Otherwise, it is remain open. So that's the reason that CR3 we are keeping parallel in parallel to CR1, not in parallel to CR2. Otherwise, I can keep it anywhere. Okay. So it will keep my master control relay MCR, which is CR3 as per this book, will remain energized all the time. Okay. So CR3 will avoid any conflict of interest between CR2 and CR1. Now, third thing, you see what is the condition mentioned? If I am going to consider the up direction, that means if I am moving towards the topmost floor, if the platform is already not moving downward direction, then it should follow my order. If it is already coming to downward direction, let it come first, hold it, then it will execute my task. What is the task? Come back to the upward direction to reach to the topmost floor. So what is the topmost floor here we have maintained? Up button will be indicated by PB3. Whenever I will press the up button, it will be handled by the limit switch 1, LS1 here is mentioned. Whenever LS1 relay will be energized, this limit switch will be energized, it will energize the master control, master control I'm saying. It will energize the motor M1. How it will energize motor M1? Using a dedicated control relay. Now, for example, here I give control relay number 4. Why? Because 3 I have already allocated to master control relay. That's the reason I am telling you to avoid any confusion. Better you take master control relay CR5. Therefore, now you can take CR3 here, CR4 here. Or if you are taking that one is CR3, so you can take CR3 here, CR4 here, CR5 here. What the author is done. So now it will take a master control, another local relay CR4 to execute up operation. Local relay CR4 will energize the motor M1. Whenever the motor M1 is energized, you know what it will do? It will pull the platform to upward direction. So that is what I need to do here. You see, forget about the rest of the thing. You see this button, this run number 5, only this much you see. Okay, only this much. That's all. Okay. So what it will does? CR3, right? Why CR3 I am bringing here? Because CR3 is a master control relay. So it will operate both upward direction and downward direction, and it will also avoid any conflict of interest between the upward direction whenever elevator is moving in upward direction or in downward direction. How it will execute? So that's the reason that we are keeping CR3 at the very beginning to take care of everything. Okay? It's like an entry gate. Without the permission of that master control relay, you cannot do anything. Now, push button 3 will be pressed. Limit switch 1 is already energized. As per this author, we have taken CR4 to operate the push button 3. So CR4 is active. Now, because it is a push button type, so I will keep this input in parallel to this. Your job is over. Done. If it is so, once CR4 is energized, what will happen? It will be normally closed. Otherwise, it is normally open button. In that case, it will be closed. So it will ask the motor M1 to drive. Forget, right now you forget this CR5. So you can simply draw CR4 and M1. That's all. To operate on up direction independently. Take now. What I will do over here to execute the downward direction, downward operation, I'll execute only this function, this one. Again, I will take CR3, master control relay, this time push button 4, right? Push button 4 is connected to limit switch 2. Why? Because both push button 1 and push button 4 will be connecting to limit switch 2, which is responsible to energize, which will be energized whenever I need to bring the platform downward direction. So downward direction will be executed by now a local control relay CR number 5. So this 5 will energize this input because again it is a push button, so it will remain here. Okay, so you see that the rung number 7 and rung number 5, they are almost dual of each other. Okay, now do I need to draw because CR5 will be energized? Which one? Motor M2. So do I need to again write a line here CR5 and M2? Yes, you can as a layman, no problem. May not be a very ideal answer, but nothing wrong. Should I need to do? So now I would say that relook to your answer over here. Okay? I would recommend to relook to your answer over here. What I need to draw? CR5 and M2. Huh? So you see, M2 is already here. Earlier my solution was what? CR1 is connected to M2. So what I will do, in parallel to CR1, I'll draw one more input here, CR5, and connect to this. Don't you think that that is more than sufficient? Rather than taking one more extra rung number 8, you can. Because start operation and down operation, both are handled. Both are ultimately asking whom to execute, motor M1. So that's why CR1 and CR5 you can keep in parallel. Okay. Now, what is this guy CR4? Because CR4, remember, is a different. CR4 is bringing the platform upward direction. So there is a conflict of interest. So even by chance, accidentally, whenever CR5 or CR1 is doing its job, what are they doing? They are bringing the platform downward direction. CR4 should never be energized. So take care of that safety operation measure. We keep CR4 in normally closed condition. That means reverse condition. If it is open, it will close. If it is closed, it will open. Okay. So that's why we are keeping CR4 in closed condition. Okay. That's the reason. So now your start operation is completely fulfilled without any conflict of interest. Downward direction operation is also complete along with the CR rung number 2. It will operate rung number 7. Okay. That is the reason for upward direction. These two rungs are operated, rung number 5 and 6. And downward direction, there is only one rung. Why? Because the parallel thing we have been executed here rather than writing one more separate rung. Here we are attached at rung number 2, just by adding one extra component. Okay? Because in this case, CR4 is normally closed, CR5 is normally open. So obviously, whenever I move upward direction, what should be done? Reverse. CR4 should open, CR5 should close. Whenever I will handle motor number M1, that's all. Okay. Now, in this scenario, what was handling by the CR2? CR2 is a stop operation, most important. So that should remain closed here. In fact, better programmers always keep, because here for your purpose only we started with the stop operation. But as a good engineer, automation engineer will always think that how to stop the operation in case of emergency without any damage. So we will always keep CR2 first, normally closed condition. Then I will draw CR1 normally open and keep CR3 here. Theoretically, both approaches are same. Practically, essence is different. Okay? So that is the complete of physical ladder diagram of this program, the two-stage elevator. Okay. Now for a meanwhile, before reaching to this optimized, what is mentioned, simplified ladder diagram, well, you see how many physical input outputs are needed here? 4, again 4 here, 8, plus 2, 10, plus 4, 14, isn't it? Here, how many number? 5. So 14 plus 5, 19, 3, 22, plus 5, 27. So 27 components, their minimum is needed. Right. Now you see in this simplified diagram how many components are needed here. Remember, both are doing the same operation. So 2 plus 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay. How many are there? 29 or 27? Huh? Something. So you see there is a save of around 11 or 12 components. Obviously the energy will be saved. Program can execute faster. But before reaching here, let me discuss with you the programmable part, and then I will come back to here. You see, here is my solution. Okay? So here it is my solution. I've been drawn in my way for your understanding. This one is a physical ladder diagram. First two rungs are operating the start operation along with the down operation and avoiding the conflict of interest with the up operation. Next two lines are drawn for the stop operation, obviously along with the master control relay, and to avoid the conflict of interest with the start operation. Then the up operation to avoid the any conflict of interest with the down operation. So here is there, and then it is a down operation. So in the programmable part, what we did that we are going to program here we are going to program here in this way. Start operation, I am keeping the address number 1. Stop operation, address number 2. You know that I've been already shown you in the instrument list how we actually in a real life scenario we address these numbers. But for our easy understanding here, we have given some 2-digit numbers. We are considering almost how many what you called inputs 1, 2, 3, 4, 5, 6. Okay, and this many number of inputs, and then start, remember, is PB1, right? And stop, what I mentioned, is PB2 already. That's why I have not mentioned PB1, PB2 separately here. Okay, so 6 inputs, 2 motors, 5 control relays. Okay, 5 is needed. So here I mentioned 6, 5 control relays needed. And right now, in this case, there is no timer. If needed, then there will be separate requirement of timers. So push button 1 is indicated by 1. Push button 2, push button, then limit switch 1, that is also input indicated by 3. Limit switch 2 is indicated by 4. Push button 3 is indicated by 5. Push button 4 is indicated by 6. You can have your own number, no problem. Okay? But go in a sequential order, that is the advice. You are using first execute, define these numbers in a alphanumeric numbers in the increasing order. But obviously, is it necessary? No. There are 2 outputs. Our output, you know that input we have taken from 0 to 7, output we have taken from 8 to 15 numbers, right? Control relays, more numbers. So we have taken 16 to 31. And timers, if needed, 32 to 39. In the one of the class in the beginning, I have been already told you for the standard understanding, we are keeping these numbers in between these 2 ranges. Again, is it necessary? Answer is no. You can have your own numbers, but define it. If you are not defining, then probably remember your answer is incomplete. Okay, your solution is incomplete. Even practically, it will never be considered. So it is a start operation. I am replacing is the input button. In very beginning, remember in the problem statement itself, here is already mentioned which one is which type of button. Start is normally open type button. Here is mentioned. All are the normally open type button. Limit switches are normally closed. Okay, so I'm following that. So start is a normally open button. So in my solution, I have taken a normally open. Okay. Limit switch is normally number 4. So it is number 4 here. Take CR1 is control relay 1, take care of the start operation. It is number 16, so it is 16. This control relay input is related to the control relay 1 energizing. So that means this input is also number 16. This one is CR1 again. Okay. So CR1, CR1 is 16. This one is CR4. So CR4 is number 19. So 19. Motor M2 number is 9. So it is 9. This one is CR5. CR5 is number 20. So here I will mention 20. Likewise, I will do this probe. Okay. This one stop operation. You can correlate here. Okay. You can correlate here. So it is like stop operation, so it will be number 2. CR2 will be number 17. Okay. Then you can consider CR1 here again. So CR1 is number 16. So you give all these numbers. 17 here. CR3 is 18. So this one is 18. This one is also 18. PB3 is 5. This one is limit switch 1. Limit switch 1 is 3. CR4 is 19. So here is remain 19. This one is also 19. CR5 is 20. Motor M1 is 8. Right? So that is 8. Then CR5 is 20. And all these things is this way. So this one is the difference. Physical ladder diagram. This one is a program diagram. Remember, I have presented this answer considering both start and stop button are normally open type. In many applications for better safety operations, we always keep, most of time, we keep stop button as a normally closed. Normally stop button always remain energized if it is a very critical operation. So that as and when needed, there should not be a wastage of time to energize the stop button. You can start straight away execute that task. Who? Automation will do. That controller will do that job. Okay. So if start button is normally open type, stop button is normally closed type, answer will little bit modified. Be careful about that. Okay. I hope that there should not be any confusion. Now coming back over, let us conclude this optimized solution, and then we can close here by addressing the new case study, and that we will discuss in the next lecture series. So here you see, can I compress my answer without violating any safety measures? So answer is yes, we can modify it. Okay, so let me take this opportunity to understand how can I modify it. Okay, so here you see what we can do, that what we can do over here. You see that what I said, that stop operation is the most important, right? So take care of the stop operation first. Which push button is used? Handling that PB2. So here I am adding a normally open type push button. It is handled by the CR2. Remember, it is a fresh program. So if I want, I can make CR1 here my control relay. No problem. Define it. What you are doing, define it. Again and again I'm saying. But to connect with the same answer, standard answer, I'm using, the author has used the same symbols. So it is CR2. Relay run number 1 is complete. Now, if CR2 is a stop operation, so it will be CR2 or any other control relay will be dictated by CR3, because CR3 you have already defined your master control relay. So how the master control relay will remain energized then? That means this CR2 has to be closed here in this line, not here. Here it will energize or de-energize its output device depending on this push button, right? If it is pushed, it is energized. If it is unpressed, then it is a de-energized ideal condition. But this input CR2, which is connected by heart from this output device, should remain energized. so that this supply will be continuous CR3. That's the reason. So master control relay तुम्हारा हो गया, stop operation तुम्हारा हो गया, ठीक है? Now what are the things? Connect everything behind two motors. M1 is taking care of upward motion. M2 is taking care of downward motion. M2 is also taking care of start operation. Right? Here you mentioned that the platform is driven to downward direction. Here you see. Correct? You can see here. Okay. So start and down will be handled together parallelly. Up operation will be handled separately, again in parallel. So you can go either up, okay, or down. Let us go for a down. Why? Because stop operation to मैंने define कर दिया. Start operation is also needed now. So here you see this master control relay is connected here because this master control relay will handle both motor M2 and M1, or in other words, limit switch L1 and L2. Thick. Or in other words, the control relay CR4 and CR5. So therefore, CR3 is here. Okay. CR3 is here. If you am pressing the push button PB4, so it will bring the platform downward direction. Why? PB4 is push button. Whenever you will push, it will energize limit switch L2, LS2. LS2 is energized. It is responsible to bring the platform downward direction. So that means it will energize motor M2. Motor M2 is energized. It will try to pull down the pulley, that cable through which the elevator platform is connected. So it will bring that platform down. Once this one is energized, I'll take another input relay whose name is M2. So it will also energize. Next time, even it is open, the current will pass through this line. Okay? I again repeat, current will pass through this line. Okay? Then what this guy is doing, M1. M1 is another input which is relating to motor M1. Now, what is responsible of M1? To bring the platform in upward direction. If M2 is energized, do you think that M1 should also energize? No, even not by accident. That's the reason we are keeping close, de-energize M1. This is an input, normally close. We are keeping de-energize M1. M1 should not operate. Then only M2 should operate. If M1 is operating, then M2 should not operate, you see. So it's a duality condition. Okay? That's the reason that along with CR3 master control relay, we are putting this condition. Check before going to do this task. Before energize what? Controller, PLC is saying to input output devices. Check whether M1 तुम्हारा energize तो नहीं है. Isn't it a start of, upward operation is active? This is that no. That means why? How do you know? Because M1 is closed. Then it will complete this task. Next time this button is released, so this line will pass through this. Now, especially for the start operation, because also it is connected, LS2 is common, M2 is also common. So I'll keep this start button PB1 in parallel to PB4, because again in that condition, these two are common. M2 is also common. Only I'll add one more start button. Now, if you want, you can press start button here, PB4 here, no problem. Okay? It's up to you. Whatever job you have done here, remember here you are executing two tasks, down and start. Here I will do only up button. Take the dual of CR other than CR3. CR1, why? CR3 is a master control relay. No? Okay, so CR3 input will remain same. Now this time M2 should not be active. M2 down button. Why? Because I am going to, PLC is going to execute the up operation. So M2 should be closed. Push button 3 will be pressed. It will energize limit switch 1. It will energize motor M1. Motor 1 is energized. It will energize the input relay M1. That's all. Okay. I hope that purpose is fulfilled. So if you have a better understanding about the program, now this modified, simplified or optimized ladder logic diagram, ladder diagram is ready. So accordingly, you can develop a optimized programmable ladder diagram. Okay? I'm leaving this assignment behind you with you as a homework. Okay? Because now there is a no written assignment format we have. So I'm keeping this for your homework purpose. So I've already given 3-4 different conditions to meet the same example. Okay? I hope that this idea is clear. To avoid not to overburden you, I'm not moving in. It's like this one is another case study. Okay, so label operations. So we will see that how the like in food and beverages industries you see, or maybe let's say for example your cold drinks or ready-made coffee, how it is being prepared. So by covering a top end closed tank and with some temperature sensors and all. So we will try to understand this case study next time. This one is again a physical ladder diagram. Once it is understanding for you, now you can develop a programmable ladder diagram. I have not told you the way how to do that. Okay? So that is this application is given. So we will discuss this part next time. Okay, in the very next class. Done. So right now, if you have any confusion, I am living with already 2 scenarios. What if the normally closed stop button is normally closed type? Then how your answers will change, solution will change. Number 2, this optimized physical ladder diagram is already prepared. So your job is to prepare a optimized programmable ladder diagram. Okay. So with this, if you have any confusion, you can ask. Otherwise, we can depart. Any questions? Okay, if there is no question, so with this, we are going to close this session over here, and I'm going to stop sharing the data. Coming back. Okay, wish you good luck. So probably try to engage one more class on the 2nd of April. 4th of April, I'm a little engaged. So 2nd of April, find a suitable time.